If you've taken the time to learn your basic integration rules, you'll see that this one, this integral, is really just an arctangent. Let me rewrite this so it's in the form that you should recognize. The integral from -2 to 2, I'm bringing the 4 out front. That's a scalar multiple, and that leaves us with 1 plus 4 over x squared dx. The rule for arctangent is that the integral of du over a squared plus u squared is going to equal 1 over a times the arctangent of u over a plus c. And that's the rule that we're using in this particular problem. Putting it in the context of our problem, we keep that 4 out front. We will go ahead and say 1 over 2 times the arctangent of x over 2, and since this is a definite integral, we will need our limits of integration, which would be from -2 to 2. Continuing on, I'm going to go ahead and take this 4 times 1/2 as a scalar multiple. And then I will have arctangent of 2 over 2 minus the arctan of -2 over 2, using the fundamental theorem of calculus. We need to go back to our trig tables to evaluate arctangent of 1, and hopefully you can remember that the arctangent of 1 would be pi over 4. Minus, and the arctangent of -1 will be -pi over 4. Arctangent always returns a value between -pi over 2 and pi over 2. With this, we have pi over 4 minus a -pi over 4, 2 pi over 4, or pi over 2. And this leaves us with simply pi as the answer to this problem. One other option that we could have seen in the very beginning is if we had recognized that our original integral right here was the integral of an even function. Since our limits of integration are the same values, just one positive, one negative, we could have said that the integral from -2 to 2 of 4 over 4 plus x squared dx will be the same thing as 2 times the integral from 0 to 2 of 4 over 4 plus x squared dx. The major reason to do something like that would be to make our evaluation a little bit easier. Sometimes it really makes sense to do that. Other times, not so much sense. I'm not sure we get a huge value added from doing that in this particular problem. Regardless, the answer that we're left with is pi.